In Lesson 4, Day 1, we worked on multiplying with scientific notation. In Lesson 4, Day 2, we worked on division with scientific notation. Today we're going to work on Lesson 4, Day 3, in which we will be adding using scientific notation. The remembering of Lars is going to come in real handy with today's lesson. So one thing I really want you to make sure that you remember is Lars. Left, you add, right, you subtract. I'll show you why in this lesson, why that is so important. But we're going to go ahead and we're going to start off with this first example. The first step that we have to follow is Step 1, rewrite so that the exponents are the same. Once you have both exponents the same, then you can begin to add. So when I look at this, I have one exponent that is a 7, and I have one exponent that is a 6. One thing that will always make your life a little bit easier is always pick the larger of the two exponents. Either one will work, but if you pick the larger of the two, it'll make it a little bit easier. I'll show you why later on in this video. So this one is the smaller of the two exponents. We're going to make that the same as 7. So in order to do that, we need to add 1. Now if we remember Lars, we added 1, so we also have to move our decimal one spot to the left. So it was 5 5/10. Now it's going to become 55 hundredths. So we're taking it out of scientific notation for the time being so that we can add our two numbers together. So we have 55 hundredths times 10 to the 7th power. And again, this is not scientific notation, but it will help us. Once we have both exponents the same, what we did second was we moved the decimal in the first factor that we changed the power for. So because we had to add 1 to our first exponent here, we also had to move our decimal place one spot. Now that both of these are written with the same exponent of 7, now we're going to look at the first factor in both scientific notations. One is 4 3/10, one is 55 hundredths. So now we're simply going to add the two together. And remember, when you add decimals, you have to line the decimals up. Now, if you use a calculator to help with your addition, that's completely fine. But if you do it by hand, you have to make sure you line up the decimals. So 5 plus nothing is 5. 5 plus 3 is 8. Bring the decimal down. We have a 4. So we added the numbers together. That was step 3. And then the last thing is to simplify and make sure that your answer is written back into scientific notation. In order to write it in scientific notation, we take the answer of adding, which was 4 85 hundredths. So we have 4 decimal point 85. It's always going to be times a power of 10, so 10. And then the exponent that we used was the exponent of 7. So then our exponent in our answer will be 7. We need to ask ourselves, is this answer written completely in scientific notation? First, do we have only one digit to the left of the decimal? Yes. And second, do we have a power of 10? Yes. So now we have added two scientific notation numbers together, and we've reached 4.85 times 10 to the 7th power. Example 2, we have 10 to the 24th power and we have 10 to the 22nd power. So we're going to pick the larger of the two, which is 24. We need to add 2 to this one to make it 24. And if we add 2, Lars tells us left you add. So we added 2. We also have to move it not 1, but 2 spots. So now this number becomes decimal point 735 times 10 to the 24th power. So even though this is no longer in scientific notation, we've taken it out. We have a common exponent so that we can add. So now we're going to go ahead and add our two factors together. I went ahead and added the two numbers together, and that gave me an answer of 6.0435. My exponent was times 10 to the 24th power. This is written in scientific notation, so now I know I'm finished. Example 3, we're going to take a look at what would have happened if I would have chosen the smaller of the two exponents. So if I want to make this one common to 13, I would have to subtract 2. So subtract 2, since we subtracted, Lars tells us right and subtraction go together. So I subtracted 2, which means I moved this decimal point 2 spots to the left, which means I now have the number 750 times 10 to the 13th power. So I then go ahead and add my two first products together. So I have 750 plus 2 and 45 hundredths. When I add those two together, I get 752 and 45 hundredths. So then my final answer would be 752.45 times 10 to the 13th power. Now what you might notice here is I have something that's not written in scientific notation. I have 3 digits to the left. So in order to get this back into scientific notation, I have to move my decimal 1, 2 spots to the left. And Lars tells me that if I move it to the left, I have to add. So then I would come back and I would add two numbers to my exponent. So then that would end up give me an answer of 7.5245 times 10 to the 15th power. Now you might notice that the bigger of the two exponents was 15. So if I would have chosen 15 in the beginning, I would have been completely fine. Now let's take a look at example 4. So I want you to go ahead and try this one on your own. So go ahead and pause right where we're at and see if you can do this one on your own. Hopefully from example 3 you learned that you should always choose the larger of the two exponents. The largest exponent in this problem was 10 to the 9th. So I saw my 6 over here. I added 3 to the 6 to make it 9. I also had to move my decimal 3 spots to the left. 3 spots because I added 3. So then once I did that, I could add my two numbers together, which resulted in 1.359235, and then times 10 to the 9th power. Go ahead and do the same thing with example 5. Try this one on your own. Pick the larger of the two exponents, and once you are completed with it on your own, then hit play and see how you did. Alright, final answer here should be 4.5008247 times 10 to the 21st power. On example 6, let's go ahead and do this one together. We need to add 3 to this exponent, which means we move our decimal 1, 2, 3. So we have decimal point 0.004548 times 10 to the 11th power. Now that we have common exponents, we can add our two first factors together, which is 1.9734 plus decimal point 0.004548. Line that decimal up if you're not using a calculator. Results in the following number. So we have 1.977948 times 10 to the 11th power. So we have a final answer here. It is in scientific notation. Generally, not always, as long as you pick the larger of the two exponents, your answer will be written in scientific notation when you're done. However, if it is not, then you need to follow LARS, L-A-R-S, and you need to adjust. So what I mean by that is, what if I follow the entire process and I'm left with something like 14.27 times 10 to the third? I picked the larger of the two exponents, but when I added my two first factors together, this is what I got. So we can identify that this is not in scientific notation. So we have to put it in scientific notation. We have to move that decimal one spot to the left. And if we follow LARS, if you move it to the left, you add 1 to the exponent. So by doing that, we end up with a final answer of 1.427 times 10, not to the third, but to the fourth after you add 1. Now we have a final answer that is written in scientific notation. Now our last example here says in 2007, there were about 7.21 times 10 to the 7th power of dogs kept as pets in the United States. In the same year, there were about 8.17 times 10 to the 8th cats kept as pets. How many dogs and cats were kept in total? So what we need to do is we need to add those two numbers together. We need a common exponent, and our common exponent needs to be 8. So I need to change that number to an 8. I did that by adding 1. So if I follow LARS, left we add. So we added 1, which means we move our decimal one spot to the left. So now we're adding decimal point 721 with the number 8.17. We add that up, we get 8.891 and then times 10 to the 8th power. Now that doesn't seem like a whole lot of dogs, but what does that really mean? So if we have 8.891 times 10 to the 8th dogs, what that really means is we need to move that decimal point 8 spots. So 1, 2, 3. So I don't have enough to move 8, so I'm going to start over here. Let's move it 8 spots together. 1, 2, 3, 4, 5, 6, 7, 8. And in each one of those loops, I need to add another 0. So based on this problem, what this is telling us is there were a total of 889,100,000 pets in the United States in 2007. Now my guess is that probably is really low of a number. So the idea behind it is this is how many pets there were. But by all means, there's probably more pets than this just in Iowa alone. So, all right, come see me for your worksheet on addition with scientific notation. If this isn't clicking or if you have questions, come see me and we can go over a few examples and hopefully clear that up as well.